Okay, so now I'm going to do problem number 2. So number 2 tells us that we are growing wheat and we're growing corn and we're using a lot of different land to do it and parceling of land. So as usual, I'm going to start with our familiar structure. So first I'm going to say, what do we produce? I'm going to change to black quick. Okay, so what do we produce? How much do we produce? With how many factors of production? And then I'm going to take careful note of the opportunity cost given. Here, they give us a lot of information about acreage, but we really don't need it. We really need to focus on what it is we produce. We produce in this economy wheat and corn. Okay. How much do we produce? Well, the problem tells us that we produce 2.158 billion, just put capital B for billion bushels of wheat, and we grow 11.807 billion bushels of corn. The acreage is the factor of production. It's what we're using to produce. And to get 2.158 billion bushels of wheat, we use 50 million acres. And to get 11.807 billion bushels of corn, we use 74 million acres. They tell us the opportunity cost at this production point, okay? So remember that we will end up making, can't get straight lines on here. Okay, well, that's pretty straight. Okay, so let's say we have wheat here, we have corn. So this is a production point on this, in this space. And they tell us at this point, the opportunity cost of producing 1 bushel of wheat is 1.7 fewer bushels of corn. In other words, at this point of production, wherever it is, so let's say that it's right here, then to get 1 more wheat from this point, so this is 1 more, I need to lose 1.7 billion bushels of corn. That's what this opportunity cost is saying. The other way to see this is that if I want to gain 1.7 billion bushels of corn, I need to lose 1 billion bushels of wheat. So I'm just going to take that away real quick. Okay, and now it says that the farmers have increasing opportunity cost, so that additional bushels of wheat from this production point have an opportunity cost greater than 1.7 bushels of corn. What does that mean? That means, now notice they use the word increasing opportunity costs. What does that mean? That means that for whatever reason, how much you have to give up to get an additional unit of wheat changes. So initially, like we said, to get 1 more wheat, we would have to lose 1.7 billion bushels of corn. Okay, so this would be the new efficient production point if we wanted one more billions of bushels of wheat. But increasing opportunity costs means that the next billion bushels of wheat that I want is going to require a bigger loss for me in corn. So maybe this is like 2.1 billion bushels of corn that I need to lose. So here is the new point. What this production possibility frontier is going to end up looking, what the production possibility frontier of for increasing opportunity cost looks like, is a curve like that. And this is the general shape of a curve for increasing opportunity costs. And this makes sense, for instance, because the opportunity cost is the trade-off, right? So consider that here we have a downward movement and then a rightward movement of certain lengths. And here we lose the same amount. Well, let's not go into that actually. Let's just go back to, forget that. Let's just stay with increasing opportunity costs is a downward curve like this, okay? And for this reason, that if I want to move up in 1 billion bushels of wheat, I need to lose 1.7 billion bushels of corn. But the next time that I want 1 more billion bushels of wheat, I need to lose more billion bushels of corn. That's what is meant by increasing opportunity costs. So part A, what this question is going to do is to say, okay, we're going to give you a bunch of production points. And we want you to tell us if it's feasible and efficient, feasible but not efficient, or not feasible or unclear. I'm not sure what unclear will entail, but we'll find out. So just to review, remember that everything on the production possibility frontier, so for instance this purple dot, is efficient. We cannot gain any more of one good without losing some of the other. So for instance, here, if I want more wheat, I must lose some corn in order to stay on the production possibility frontier. And the production possibility frontier just represents all the combinations of corn and wheat that my economy can produce. If I'm in this space, then my production is feasible, but it's not efficient. I can make more. If I'm out here, this is not feasible. I can't make any combinations of corn and wheat that are outside of the bounds of the production possibility frontier. So that's kind of what this question is sort of getting us to think about. So let's consider the first. The first says farmers use 40 million acres of land to produce 1.8 billion bushels of wheat, and they use 60 million acres of land to produce 9 billion bushels of corn. The remaining 24 million acres are left unused. Okay, well here the acreage again is not exactly useful, but let's consider again where we are. This is corn, this is wheat, because a lot can be taken from just kind of common sense of this problem. And we consider a production point that is, say, over here, and this is the point that we started at. This is the point 11.807 to 0.158. This is the original production point that we were given. And we know that that point is efficient because they tell us it's efficient. And we know it sits on the production possibility frontier. And we know that that production possibility frontier is a curve. And that it's a curve because of its increasing opportunity cost. So it kind of looks like this. Okay? So now they tell us that let's consider a new production point. Let's consider the point 9, because that's a billion bushels of corn, and 1.8. Okay, and let's consider where 1.8 would be on this graph. So if this is 11, if this is 11.807 and 2.158, then 9 and 1.8 is somewhere kind of like around here. Right? That's just the common sense of graphing, which means that this point here must be feasible. We can produce it, but it's not efficient. It doesn't lie on the production possibility frontier. Okay? And another clue from this problem that this would have been a feasible but not efficient production point is that they tell us we have 24 acres of land that are unused. So it's kind of common sense that this is not an efficient point of production, because an efficient point of production is the max you can produce with what you have. Okay? So next video we're going to do part B, but the answer for part A is feasible but not efficient.